afternoon class. In our previous lesson, we talked about ideal gas laws.
Yes.
Yeah? Ideal gas laws. And your homework was two connected balloons.
Yes.
Do you remember?
Yes.
This is my work.
So, today's our learning outcomes. You have to describe change of macroscopic parameters. Do you remember what are macroscopic parameters?
Pressure,
Volume, temperature.
And temperature, yeah? And through experimental work, you have to prove Boyle's law. Boyle's law. And plot and analyze graphs of isoprocesses and also redraw graphs of isoprocesses. These are our learning outcomes. Okay, any questions? I mentioned it. Your home task was two balloons. What happens?
the smaller balloon will get smaller and the big balloon will get bigger.
No, it
No,
yeah.
pushes
What's
air,
your answer?
pushes air to the larger balloon, and then larger balloon will expand.
Volume of balloons will be equal.
Okay, yeah? There are several ideas, yeah? Arafat thinks that smaller gets
Smaller.
smaller.
The big gets bigger.
Ercan, you are saying that bigger gets smaller, yeah? Okay, let's check. You see?
Yes.
Why?
Because we have a lot of pressure on the right side, and that's why when we are trying to make balloon bigger, that's much harder than if it's already big.
Well done. Any questions?
No.
Okay, thank you. There are explanations here. As we talked, you can read. I will that for you, yeah? Isoprocesses, isothermal process, isobaric, isovolumetric, absolute temperature, pressure, volume, and macroscopic parameters. It's called collapsing can. Collapsing can. Have you ever tried to do this experiment?
No.
Collapsing can. So, okay, let's experiment. To do this experiment, we need several cans, yeah? Coke cans, and water, cold water. You see?
Yes.
With ice, yeah? And we need oven. Its temperature is 495 degrees. Very hot. Also, yeah, we need gloves in case when cans are very cold, yeah? Very hot. So, these are process of collapsing experiment, yeah? Cold water with ice, yeah? And I need to put some water into cans, just small amount of water. I need to put into a small amount of water. And we need to wait, yeah? When the water boils, yeah? This one is actually already let's wait here. flows here. So I need to put this can quickly into water.
Cold water.
Cold water, yeah?
Yes.
Okay, let's try what happens here. You see? Collapse. Who wants to try?
Me?
Azhan?
Yes.
Okay, go on. Upside down. Upside down.
Быстрее,
Open. Quickly. You need to do quickly. Okay.
Such a fail.
So, it's your fault.
Окей, на языке.
Next.
I think it will be.
Quickly, upside down.
Выйду на языке.
Upside down into water. Wow. Okay.
What's next? Jump.
So, if you put, yeah, you can try this one more, yeah? So, question is, why?
Because probably when
Very,
pressure is high.
very quick change in temperature. It caused such collapse.
Quick change in temperature.
Yeah.
In the pressure.
Because the
Example.
pressure is greater outside.
Because pressure have a connection with temperature.
Okay. Any ideas?
If there will be any change in temperature, then there will be any.
What about water vapor inside this can? So one more. Who wants to do it? Arafat? Quick upside down into cold water. Yeah. Immerse it. Whoa. That was much more better than previous one, yeah? So, okay. So why? Any idea?
Because when we heat the can, the vapor that came inside, it air is pulled out by the
Okay.
vapor.
So, what happens then?
Because of the differentiation between the outside pressure and the inside pressure, the pressure outside causes the can collapsing.
Well done. Thank you. So, now we explain can collapsing experiment, yeah? This is an answer. Also, she gave us beautiful answer. So, quantity of gas related. Is it clear?
Yes.
What does confined quantity of gas mean? Certain. Yeah, constant amount of
Gas.
gas or constant mass of
Gas.
gas. Okay? So, if it's clear, we can start. Yeah? These are materials required to do this experiment. Yeah? If you have any questions, feel free and please read carefully. Yeah? Please read carefully. If you have any questions, feel free. Ask.
why V is also, every time it's constantly not changing. So even if we'll change the height or pressure, then it will be the same. So
Did you get product PV
It's constant, yeah.
constant?
Yes. And while V is increasing, P is decreasing due to the graph.
So almost constant.
Yeah,
Yeah.
that's right.
Yes.
Now in your experiment, we proved that Boyle's law is
Working.
working.
True.
True or false?
It's true.
Okay, Boyle's law is true. PV is constant. Why temperature is constant?
Temperature?
Temperature.
because it's not changing, we are not heating anything or
Yeah.
cooling.
Yeah, we are assuming that room temperature is
Constant. Same.
constant, the same.
Isothermic.
Isothermal process. Okay, thank you.
Finished.
Now you need to reassemble your instrument.
Ah, okay.
Please. Let's analyze PV diagram. So if given the graph of isoprocesses 1, 2, 2, 3, 3, 1, closed cycle, how to redraw these processes into PT and VT diagrams? So our first task is redraw these processes into PT and VT diagrams. First of all, we need to write gas loss equation. PV over T is constant. Now we need to analyze the processes. First, 1 to 2. As you can see, 1 to 2 is V constant. If which process is constant, we can cover V. Now, consider that P over T is constant. So if, as you can see from the graph, P is increasing from 1 to 2. So if P increasing, T is also increasing. Second, 2 to 3, T is constant. If T is constant, as you can see from the graph, pressure is decreasing, thus volume is increasing. Also you can have a look, volume V2 is increasing till V3. Third one, 3 to 1. 3 to 1 is P constant. So if P is constant, V over T is constant. From our graph, V is decreasing. So if V is decreasing, T is also decreasing. Now we need to draw PT diagram. We start to draw from a free moving point. So this is point 1, dot 1, free moving. Anywhere we can start to draw. So 1 and 2 is V constant. If PT diagram, V constant will be directly proportional line. So up or down. So from our graph, you can see that P is increasing, T is also increasing. So we need to draw up line till 2. So 2 to 3, T is constant. If T is constant, our graph will be vertical line. So vertical line in which way? Up or down? So now let's have a look at our analysis. P is decreasing. So if P is decreasing, we need to draw down. 2 to 3. Now finally 3 to 1, as we know, P is constant, so it means our graph will be horizontal line into till 1. So now we finished PT diagram. Now we need to redraw this diagram into VT diagram. So again we start to draw from a free moving point. 1, 2 is V constant. It's obvious V constant is horizontal line, but in which way? Again we need to see. In our analysis, temperature is increasing. So if temperature increasing, we need to draw a horizontal line to the right. So 2, 3 is T constant. So T constant will be vertical line. And finally, P constant. If VT, P will be from 3 to 1. So it's down. Because volume and temperature both are decreasing. So that's all. Now we finished analyze and plot task number 1. In a similar way, we can analyze and plot PT and PV diagrams. Gas loss equation, PV over T is constant. 1 to 2 is P constant, isobaric process. If it's V is increasing, T is also increasing. 2 to 3 is isovolumetry process. T is increasing, thus pressure is also increasing. 3 to 4, temperature is constant, isothermal process. If isothermal process, temperature is constant, you can see volume is decreasing, pressure is increasing. Finally, 4 to 1 is V constant, isovolumetry process. V is constant, T is decreasing, P is also decreasing. Now PT diagram. PT diagram is 1, 2 is P constant, 2, 3 is V constant, 3, 4 is temperature is constant. Finally, V is constant, temperature is decreasing, pressure is also decreasing. Our PT diagram will be like that. Now PV diagram is, again we start a free moving point. It's P constant, horizontal line, V constant, vertical line, and T constant is PV is indirectly proportional. And finally 4 to 1 is V constant, but pressure is decreasing, 4 to 1. That's all. Task number 3. Again, given PV diagram, we need to plot and analyze this graph and redraw PT and VT diagrams.
From the graph, we can see from 1 to process, it is when P constant. When P constant, volume increases, thus temperature will also increase. 2 to 3 process is when volume is constant pressure will decrease, and thus temperature will also decrease. 3 to 4 process is when temperature is constant. When temperature is constant, pressure will increase, and thus volume will decrease. From 4 to 1 process is when volume is constant. So pressure will decrease, thus temperature will decrease. Now let's redraw PV diagram into PT diagram. On y-axis we put pressure, and x-axis we put temperature. So let's consider the first process, 1 to 2, is when pressure is constant. When pressure is constant, temperature will increase. So we can draw our graph from random dots. Start our graph from random dots. Let's put this. When pressure is constant, temperature is increases. Temperature is increases and volume is increases too. From 2 to 3 process, volume is constant. So our pressure will decrease. So to draw this situation, we should draw lines from 0. So when volume is constant, P will decrease. And temperature will also decrease. The third process is when temperature is constant. We assume that temperature is constant and pressure will increase. Pressure will increase and volume decreasing. The last process is when volume is constant. When the volume is constant, pressure will decrease to the first position. So now we get the PT diagram. So now let's redraw our diagram into VT diagram. In order to draw VT graph, we put volume on y-axis and temperature on x-axis. So in isobarus, we should start from 0. So let's. And according to this line, we can put any random dot and consider the first process when pressure is constant, volume is increasing. So 1 to 2 process, and temperature will also increase. When the volume is constant, pressure will decrease and pressure will decrease and volume is constant. And when the volume is constant, pressure will decrease and the temperature will decrease too. So now we get a VT diagram.
outline of the lesson. Today we talked about changes of macroscopic parameters P, V and T, and in experimental work we proved that Boyle's law is true. We analyzed graphs of isoprocesses, isobaric, isovolumetric and isothermal processes. And finally we redrawn the graphs of isoprocesses in a different way. Your homework is, there are two balloons. One is empty, second one is with the water. So, if I bring the flame with the same distance, the second balloon remains intact. Why? Try to do this experiment. Thank you. If you have any questions, feel free. Email me. See you next week.